Hello everyone and welcome to the EGEE 437 Jupyter tutorial. In this tutorial I'll be guiding you through the process of installing Jupyter and Anaconda and helping you with your homework 1. Alright then, let's move forward. First thing you need to do in order to have Jupyter running in your computer is to download it. Jupyter can be easily downloaded when you install Anaconda. It's like an integrative platform that has Python, it has Jupyter, and it can make them communicate. Alright, so then basically type on Google Anaconda download. The first thing you see is this website continuum.io/downloads. Here's where you can download Anaconda. Just move down. You can download it for Windows, Mac or Linux. And here you go. The last version is Anaconda 4.2, and you can choose if you want to install Python 3.5 or Python 2.7. The difference is more the way you type your commands, so it's a little bit different in Python 3.5 comparing to Python 2.7. Python 3 is the newest version. It's been more heavily updated, so I prefer this one, but you can choose either one. Just make sure you are using the right commands, right? And then you have to choose 64-bit and or 32-bit, depends on your computer, right? In my case I just I have a 64-bit computer, so I prefer to download it. Just click here, save the installer and follow the process. It's quite easy. You just click next and you'll be installing Anaconda, right? I'll cancel it because I already have it. And let's say you finished to install your Anaconda. Just go to, in case you're using Windows like me, go to your start menu, find Anaconda 3 or 2 depending the version you downloaded. Click here and find Jupyter Notebook. Don't mind the other things here, you won't use it right now, but you will use Jupyter Notebook. So click here. This black screen is normal. It's Jupyter loading the packages and things it needs to work, and you'll be prompted to your home folder, Jupyter home folder. So now basically you have to do is go to your canvas, download the template hwk1.ipynb and upload it to your home folder here. Just click upload, find your file and open it. You'll see it will appear here just like my case. Click on the file and you'll be prompted to the file. It takes a while to load because it's a big file, let's say so. But here you go, it's done. Here you can see all the homework problems and space for you to code, space for you to answer your problem. I'll be showing you in a minute, so let me just officially start the overview. Right, I strongly recommend you to run all the cells, right? Because if you don't do it, some packages here won't be loaded, and you need those packages to make everything run. To run a cell, hold shift and press enter. This cell has just So here, the first thing you have to do is to change the name of your group. So when you double click, let me show it again. When you double click a cell in Jupyter, you see its raw code. Here you can see some HTML coding, which is me telling in Jupyter what I want it to show. Like I want to show this font number 4, align center, and this is what I want it to show, like due date, Thursday, etc. You can see it does what I want. Double click here, select this XY and change to the number you wish, let's say 01. Shift enter again, it's changed, right? Below that you can see a space to insert your name. Once again, double click, find the name you want to replace. In case my name, replace by your name in your PSU ID. I don't know, Luke LLK7 for example. You see Luke LLK7. Quite easy. Now the packages. Shift enter this cell, don't change anything here. Below this first cell, it's done, it's loading the packages. This is probably the most slow cell to run. Below that cell you can see this one. It just shows you which version of Anaconda and Python you're using. Shift enter and you can see I'm using Python 3.5.2, Anaconda 4.2.0, 64-bit, so it's just information. Third cell, really important. Here I'm defining the trigonometric functions you need in problem 12. And why am I doing it? Because if you just try to type the angles like you're using for the problem, 10 degrees, 45 degrees, 6 degrees, if I'm not wrong, you get the answer of a sine or cosine in radians, and that's not what you want. So here I'm just converting it to degrees, so you can just type cosine d, the angle you want in problem 12, and it will give you the answer in degrees. Don't forget to run this cell. I try to provide many tips and hints for you guys to make your life a little easier here, because we want you to learn about solar, so your focus here is on learning solar, developing your skills and thinking about it. Of course you need, at some point of your life you need some programming, so this is going to help you in the future, but it's not the focus here. Just think it as a tool. You have to know how to use this tool, but more than that, you have to know why you're using this tool. Okay? Just keep shift entering the cells, more, one more, and now we're in problem 1. So, problems. In this first problem, you just have to upload your sketch and place it in here. You can see you have a image package loaded before, so you just go to this answer space, find the cell you want to insert your image, and uncomment this comment, please. And you should specify where your file is in your computer. My hint for this would be to find the file you wish, click with the right button and properties. You find the whole path. Basically copy and paste it here. Don't forget to change to like this kind of slash. Windows use backslash when specifying a file path. Jupyter use slash, so be aware of that. That's it for problem 1. And as I said before, you can either draw it by hand, take a picture of your sketch, upload it to your computer, and then place it in here using this command. Or you can draw it using your computer, some kind of computer program like Inkscape or even Paint if you wish. We just want to see your sketch. It has to be a good sketch, but don't worry about how you're going to do it. Just do it. Problem 2, the same idea. You just have all the problems have the same basic look. Problem number something, the question, a space for you to answer. Again, you have to upload a sketch here, not a problem. In this case, problem 2, number 2, it requires you to enter some text to answer the problem. Again, find the cell, double click the cell. You don't need to worry about these comments here because they're just me defining what kind of font I want to use, the size of the font. Just erase this part and write down your answer. And it will appear. Quite easy. Problem 3 requires you to make some calculations, perform some calculations. Again, many hints. You won't have problem, I hope, to code this, but if you do, just send me an email or come to the office hours. And in this problem, it also requires you to insert some equations in order to properly answer the question. So here I provided you an example of how to do it. You have some text, just like problem 2. You have an equation that I inserted, and you have the final answer. Remember, just an example. But how you change it? So here we have HTML working again to make this part of the text work with the font I've chosen and the size of the font I've chosen. And here we have the mathematical equation. This is LaTeX. This is how you would write down your equation in LaTeX, using LaTeX. Basically, you just have to change it to by the equation you wish to enter. For this, you need some knowledge of LaTeX, basic knowledge, real quick. So you have to know how to, for example, to make alpha. I don't know for this problem, but if you need to insert an alpha, for example, you would do like this, /alpha, and it would appear here. To help you guys with that, I've provided some useful links about how to code mathematical equations in LaTeX. Again, trying to make your life easier. I'll just erase that because it's wrong. And now you go to problem 4. Problem 4 requires you to code the black body fractions by numerical approximation. You use this script in the following two problems. I think problems 5 and 7, if I'm not wrong. Anyhow, you're using this for more problems. Again, I give you some hints. I define the input and the function. Gamma function is also x function in your textbook. So you'll be dealing here with Planck function. Be aware of that. So laws of light, stud them, especially Planck. You have to code Planck function here and then sum the fractions, right? Problem 5, you have the same idea. You have a space for you to code your answer, a space for you to properly show your calculations, and the final answer. This is basic for all the other problems. So when you finish answering all your questions, just click with the right button here anywhere in your homework page and go to print. You see it will show all the work you've done so far. Print as a PDF and save it in your computer when you finish, of course, and then upload both PDF and the IPYNB file to Canvas system. Alright, so just cancel this and keep showing you. The last thing I want to show you is actually about problem 8, because it has you have to plot the Bose-Einstein distribution. Again, I provide you some hints. The inputs you need are listed here, and the way you plot is also shown. So those comments are all trying to define what you want to plot. So I call the package, I specify the size of the plot, I made sure there's no old plot in the memory, and here I'm just setting what I want to be shown, like the title, the axis titles, and what I'm plotting actually. So here you have to, the only thing you have to change is in here, and if you want to change the line width, you change it here. Just put 2 if you want to make it bigger. So let me go back here to problem 5, actually problem 4, because here is where I define the temperature, the constants you need in problem 8. So it's all defined above, sorry. And when you're dealing with your homework, be sure every time you open your homework, if you're not going to, probably you're not going to finish in one day, so the time you open it again, you have to run all the code again, otherwise you have an error. So let's make sure everything will be working, because I want to show you guys the graph. Here we go. So I'm defining here. Here I have this thing you're going to use. It's you're creating a vector of numbers. So when you plot many points. That's what makes you have your the shape you want of your distribution, right? Okay, and so here I'm going to, if you see this line, it's a blue line. I'm going to change it for let's see, red line, and I want it really big. Shift enter. You see? That's what happens. This is not the shape of your function, right? But so make sure you just change this part here. All the rest is defined, correctly defined, so you don't have to change. Again, you have to worry about the important part of it, right? Problem 9, you basically have to code it again, but changing the temperature, I guess. And problem 10, the same idea. And now for problem 11, 12, I try to provide you as many hints as possible, and I hope that helps you to develop your homework. You can see at least I try to make it quite straightforward, so you have all your questions in one location, you have space for you to provide your answers, and it's organized and kind of beautiful, so it is professional work, you know. It's not just raw code. You can see, you could present it, and you will present it if you choose to use this template. The good thing is you don't have to worry about having to install one software, so let's say Scilab, and then run the code in Scilab, export the outcome to LaTeX, and then coding LaTeX. No, it's all in one place. You just have to worry about, okay, what's the problem asking me, and how am I going to solve it. That's all. There's a little coding, but not too much, so you won't be, I hope you won't be stuck on coding. But again, if you have any doubts, please just come see me. We have office hours every Mondays, 2 to 4 p.m. You can also find me in my room, Hosler 228 Hosler building. You can email me. Feel free to contact whenever you need. Alright? Thank you guys, and I hope you like it.